Welcome back to our little corner on the web, where we go over math problems to hopefully inspire and nurture an interest in math. Today, we will go over questions 4 through 6 in part 3 of the 26 PMO qualifying stage. Question 4. Let ABC be a right triangle with hypotenuse CA. Suppose AB is 12 and BC is 5. A square is inscribed in this triangle in two different ways, as shown in the figure below. The ratio of the length of PQ to that of DE can be expressed as m over n, where m and n are relatively prime positive integers. What is m plus n? So here, our job really is to find the side lengths of those squares, because PQ here is the side length of the square, and DE here is also a side length of the square. So we will try to use as much of similar triangles as possible to be able to get at the side lengths. So we know that this triangle here, EFC, is similar to DEF, and is similar also to the larger triangle. So we know that the ratios of the lengths of the legs are 5 is to 12 is to 13, just by knowing our Pythagorean triples. So we could write the ratio in EFC of the two side lengths as basically EF, or we'll call it side 1, is over 5 minus side 1. Basically, EF is to FC, should be equal to AD is to DE. AD is no more than 12 minus S1, or side 1, all over side 1. Okay, cross multiplying, we get side 1 squared is equal to 60 minus 17S1 plus S1 squared. Okay, so simplifying that, we get S1 is equal to 60 over 17. Okay, so that is DE. Okay, that's basically DE. Okay. On the second one, and maybe it's a little trickier here, we will try to find this height. Okay. We know that the area of the triangle is 30. So AC times that height over 2 will give us that height. So that is basically, AC is 13 times, not times 2, but over 2. Okay, so 30 is equals to 13h over 2, or h is equal to 60 over 13. Okay, so that's this h here. So again, by similar triangle, we know that AC over h should be equal to S over a smaller height right there. So each of those dimensions we sort of know. Well, let's just call that H2, right, over H2. Okay. Each of those dimensions we sort of know. AC is 13. H was 60 over 13. S is the one that we don't know, so we put that S2 to differentiate from the S1 that we have on the other side. And H2 is no more than 60 over 13 minus S2. Okay. So doing some cross multiplication and simplification, we'll just put it here. We get 60 minus 13 S2 is equal to 60 S2 over 13. Okay. So that means that 780 is equal to 60 S2 plus 169 S2, or S2 is equal to 780 over 229. So we want the ratio of that S2 is basically PQ. So we want the ratio of PQ to that of DE. So we want basically the ratio of S2 over S1. So that's 780 over 229 all over 60 over 17. This simplifies out to uh, 13 times 17 over 229, or that is also 221 over 229. So we want the sum of the numerator and the denominator. These two are already relatively prime. So m plus n is no more than 221 plus 229, or 450. Okay. So moving on to the next problem. Question 5. For a non-negative integer n, we define s of n to be the sum of the decimal digits of n. Define f of n as the summation from n from lowercase n equals 1 to uppercase n of the absolute value of s of n minus s of n minus 1. How many positive integers less than 2024 are not equal to f of n for some n? Okay, the wording is needs some time to sort of parse through. But what the last statement means, this statement where, how many positive integers less than or equal to 24 are not equal to f of n for some n, means that for the set of, let's say, integers 1, 2, 3, 4, all the way to 2024, how many of those will not be equal to some f of n? Okay. So for example, right, f of 1 is equal to 1, because that's sort of s of 1 minus s of 0, which is 1 minus 0. Okay. F of 2 is no more than s of 2 minus s of 1 plus f of 1, okay, which is 1 plus 1, which is 2. And you'll find that we just keep adding 1 up until f of 9. So f of 9 will be equal to 9. You can sort of do the work there. And then f of 10 is equal to absolute value of s of 10 minus s of 9 plus f of 9. So this becomes absolute value of 1 minus 9 plus 9 equals 17. So as you can see here, we skip the values 10, 11, 12, 13, all the way through 16. So there's some values here in the middle that was skipped. Okay, so we're trying to find how many of those values are skipped. Okay, so note that all the skips will happen when the term that we're looking at has the unit digits goes from 9 to 0, because the sum of the digits of that number will be less than the sum of the digits of the number that ends in 9. For example, the next one will be f of 20, f of 30, f of 40. So the skips will happen every time we hit, let's say, a multiple of 10. So here, if you notice, we skip 7 numbers. Okay. So now the question is that true also for f of 20? Actually, it is true for all multiples of 10 that are not multiples of 100 or 1,000. Okay, so f of 20 will be s of 20 minus s of 19 plus f of 18, or f of 19, sorry, which will be equal to 2 minus 10, which is also basically the absolute value, which is also 8 plus f of 19. So we also skip 8 there. Sorry, skip 7, okay? Because normally we would add 1, but now we're adding 8. At f of 100, we skip actually more. So in the multiples of 100, as you will see here, s of 100 minus s of 99, what's f of 99? instead of adding 1, we will be adding 17. Okay, so here we skip 16. Okay, skip 16 numbers. And for 1,000, for every 1,000, it ends up that we will skip 25 by the same logic. Okay, so we can actually find an expression for the function of a 4-digit number. Okay, so let me erase here, and then I'll try to motivate what the expression we will have for the function of a 4-digit number. So a 4-digit number, okay, let's say it's ABCD, will normally have the value of the number plus however many we skipped. Okay, so the value of that number, if we start with that number as a base, is 1,000A plus 100B plus 10C plus D plus the numbers that we skip. Remember, every 10, we skipped 7 numbers. So for every multiple of 10, we will skip 7 numbers. So 7 times, well, there's 100A plus 10B plus C tenths. Those are the number of tenths that we have for some 4-digit number. Okay. For every 100, we skipped 16 a while ago, but that means we already counted 7 in the tens. So we need to add an additional 9 skips for the hundreds. The hundreds is no more than 10A plus B hundreds for that for a 4-digit number. And we will skip another 9, meaning we skip 25 for the 1,000. So we'll skip another 9 for the 1,000. There's 8,000s. Okay. So if we can find an f of some 4-digit number that is equal to 2024, then we simply know that the number of skips is skips will be equal to 2024 minus the 4-digit number. Okay, ABCD. Okay. So let's see if we can sort of find that. Okay. So here, hopefully it's obvious that. Okay. Well, actually, let me rewrite that first to be simpler. That's simply 1799A plus 179B, 179B plus 17C plus D. Okay. So here, A has to be 1, or else we will overshoot 2024. So A is 1. So we end up with 2024 minus 1799 left. Okay, so that's 5 to 225. So B also has to be 1. Okay, and we will end up with 46. So C has to be 2, 34. But D ends up being 12, which can't be the case for us because we're dealing with digits. So that means that there's something weird going on around 2024 if we're trying to find a number that lands exactly at 2024. It might even be the case that there is no what do you call this? There's nothing that maps to 2024, but the only way to be sure is to see if we can calculate f of 1129. Okay. So what's f of 1129 given what we had a while ago? I'll rewrite it here. F of ABCD is equal to 1799A plus 179B plus 17C plus D. So f of 1129 is equal to 1799 plus 179 plus 34 plus 9. Okay, this is equal to 2021. We know that every tens we skip 7. So it turns out that we will indeed be skipping skip 2022, 2023, and 2024. Okay, so we at least have 3 skips here. And in addition, there's also 2021 minus 1,129 numbers that were skipped. Okay, so this is 892. So the numbers below or equal to 2024, which cannot be values of f of some n, there's actually 892 plus 3 of them, or 895. Okay. Okay, moving on to the next problem here. Oops. Okay. Question number 6. Let x1, x2, x3 be real numbers such that x sub k is greater than negative 2k, for k equals 1, 2, and 3. And x sub 1 plus 3x sub 2 plus 5x sub 3 is less than or equal to 28. The minimum value of the fraction 1 over x sub 1 plus 2 plus the fraction 3 over x sub 2 plus 4 plus the fraction 5 over x sub 3 plus 6 can be expressed as m over n, where m and n are relatively prime positive integers. What is m plus n? Okay, so typically with minimization, maximization, we try to work with positive numbers. So we'll try to somehow express the x sub k's as positive integers or positive numbers, positive real numbers. So here we know that x sub 1 is greater than negative 2, x sub 2 is greater than negative 4, and x sub 3 is greater than negative 6. Okay. So that we're dealing with positive numbers, I will let A be equal to x plus 2, x sub 1 plus 2, B be equal to x sub 3, or x sub 2, sorry, plus 4, and C will be equal to x sub 3 plus 6. Okay. So now A, B, and C will all be greater than 0. Okay. So plugging that into here first, we get A minus 2 plus 3B minus 12 plus 5C minus 30 is less than or equal to 28, or A plus 3B plus 5C is less than or equal to 72. Okay, so that's one constraint that we have. Okay, rewriting this fractional expressions that we have, this one becomes 1 over A plus 3 over B plus 5 over C. So we're, in essence, trying to minimize 1 over A plus 3 over B plus 5 over C. Okay. Notice that what we're minimizing and our constraints look like reciprocals of each other, or each term looks like the reciprocal of the other. It sort of hints that we should use Cauchy-Schwarz, okay, inequality. I couldn't find a simpler solution, or a simpler, easy solution that doesn't use it. So for those of you who are not familiar with it, I encourage you to look it up. But Cauchy basically said that for two series, x1, x2, xn, and a series y1, y2, yn. Okay. This relationship holds, which is x sub 1, y sub 1, plus x sub 2, y sub 2, plus the pair of the products x sub n, y sub n, squared is less than or equal to x sub 1 squared plus x sub 2 squared. So the sum of the squares multiplied by the sum of the squares of the y's. Okay. So in our case, okay, we can set the following mapping. I can change colors. Okay. x sub 1 squared will be 1 over a. X sub 2 squared will be 3 over b. X sub 3 squared will be 5 over c, just to make it easy. So y sub 1 squared will be a. Y sub 2 squared will be 3b. And y sub 3 squared will be 5c. Okay. As you can see, if we multiply x sub 1 squared to y sub 1 squared, we get 1. We take the square root, we end up with 1 plus x sub 2 squared times y sub 2 squared gives us a 9, but we want x sub 2, y sub 2, so that's a 3. X sub n, y sub n, we only have 3 terms, so for us, it will end at the third one. X sub 3 squared, y sub 3 squared is 25, but we want just x sub 3, y sub 3, so that's 5. That thing squared should be less than or equal to the squares of our series, but we defined x sub 1 squared to be 1 over a, x sub 2 squared to be 1 over 3 over b. So to us, this is simply the sums of the squares. A plus 3b plus 5c. Okay. We want to minimize this expression here. So let's try to transfer the other expression or transpose the other expression to the other side. We simply have 9 squared all over a plus 3b plus 5c is less than or equal to 1 over a plus 3 over b plus 5 over c. To minimize the right-hand side expression, we need to maximize the denominator. Okay? But the denominator is bounded. The denominator can have a max value of 72. So therefore, this side is nothing more than 81 over 72, which simplifies to divided by sorry, which simplifies to 9 over 8. Okay, when you divide both numerator and denominator by 8. So this m is basically nothing more than 9, and n is nothing more than 8. So the sum of m plus n is 17. Okay, so hopefully these solutions were helpful and educational. If they are, do hit the like button and subscribe. Thank you for watching.